Okay, today is day 2 of our conditional probability notes, and yesterday we did conditional probability when we were looking at two-way tables. Okay, so two-way tables that summarize the relationship between two categorical variables. Today we are going to use tree diagrams as another method for organizing information between the relationship of two categorical variables and helping us with conditional probability questions. It is especially useful to use tree diagrams when we know the conditional probability of a second event, given that the first event has already occurred. So our first example says Apple has created two types of iPads, the basic and the deluxe models. Over the past year, 40% of the iPads have been the basic model. Of those buying the basic model, 30% purchased an extended warranty, whereas 50% of purchasers of the deluxe model bought the extended warranty. Draw a tree diagram to illustrate this question, and then we're going to answer 3 questions about it. So, first, we need to decide there's 2 types of iPads, basic and deluxe. So I'm going to start my tree diagram with 2 branches. One for the basic model and one for the deluxe model. And we're going to put the corresponding probabilities along the branch. It says 40% of the iPads sold are basic. So I'm going to put 0.4 along the basic branch and 0.6 along the deluxe branch. Now, from there, we're going to branch out the option of the extended warranty. So they either get the extended warranty or they don't get the extended warranty. And same from the deluxe model. They either get the extended warranty or they don't get the extended warranty. Now, for basic, it says 30% of the purchases of 30% of those who purchase the basic model get the extended warranty. So if 30% get the extended warranty, these are complements of each other. So this must be 70% don't who buy the basic model. Now, for the deluxe model, 50% of purchasers get the extended warranty, which means 50% must not get the extended warranty. Now, it says, what percent of individuals who purchase a basic iPad without an extended warranty? So what percent purchase a basic iPad without the extended warranty? So that's this branch right here, basic iPad and then no extended warranty. So you follow that along. So 0.4 for basic and no extended warranty times 0.7. Equals 0.28 or 28%. Now, what percent of individuals purchase an extended warranty? Well, there's 2 ways you can purchase an extended warranty. You can purchase an extended warranty by buying the basic model, or you can purchase an extended warranty by buying the deluxe model. So we're going to figure out the probability of each branch, then add them together. Since it's this branch, and we learned in a previous set of notes that or means add, this branch. So 0.4 times 0.3, or means add, this branch. Deluxe and extended warranty, which would be 0.6 times 0.5. 0.4 times 0.3 is 0.12 plus 0.3, which gives us 0.42 or 42%. Now, last question. Given a purchaser bought an extended warranty, what's the probability they purchased the basic model? Okay, let's write this out. Given, so we learned this yesterday, this notation. Given they bought an extended warranty, We want the probability that they purchased the basic model. Okay, now remember, our denominator is out of what's given. We're given for sure that they purchased an extended warranty. Well, we just found that probability above. That was 0.42. So that's my denominator because it's just out of the people that purchased the extended warranty. The numerator is my overlap. They purchased the basic model and an extended warranty. Well, the basic model and an extended warranty would be 0.4 times 0.3. So my numerator is 0.12 divided by my denominator, which is 0.42. That gives me, I'm going to round that up, that gives me about 0.29 or 29%. Okay, if you'd like, you can pause the video right here and try the Your Turn on your own and then start it again once you've done it, or you can follow through the Your Turn examples with me. Okay, for this next question it says, a high school basketball team leads at halftime in 60% of their games. The team wins 80% of the time that they have the halftime lead. However, only 10% of the time that they do not have the halftime lead. Okay, let's make a tree diagram. So let's start off with, because whether or not they win depends on whether or not they were leading at the half. So that's going to be the first part of our tree diagram. Two branches. The team either leads at halftime or they do not have the lead at halftime. So they said they're leading at halftime in 60% of the time, and the other percent is 0.4. Because remember, they're complements of each other, so together they have to add up to 100%. Then from there, they either win the game or they lose the game. Now, when they lead at halftime, the team wins 80% of the time when they have the lead at halftime. So this is going to be 0.8, and then that means they lose 20% of the time. However, when they don't have the lead at halftime, that says they only win 10% of the time. Therefore, this is 0.9. Okay, first question. What's the probability a team wins a game this season? So find the probability that they win. Okay, well, there's two ways they can win the game. They can either have the lead at halftime and win the game, so this branch, or they can not have the lead at halftime and win the game, this branch. So it's lead at halftime and win, and means multiply, so 0.6 times 0.8, or, remember, or means add, they don't have the lead at halftime, and they won the game. 0.6 times 0.8 is 0.48, plus 0.4 times 0.7, 0.28. Oh, I'm sorry, this is 0.4, sorry, this is 0.4 times 0.1. That branch is 0.1. So this should be 0.4 times 0.1 is 0.04, for 0.52 or 52%. Number 7, this is a conditional question. So we're given that they won the game. What's the probability they were not leading at halftime? Okay, so our denominator, we know for sure they won the game. And in the previous question, you just figured out the probability they won the game, which was 0.52. So the numerator is the overlap. What's the probability they were not leading at halftime and won the game? So not leading at halftime and won the game. No lead at halftime and won the game. That's going to be this branch right here. So not leading at halftime was 0.4. And then the probability they won the game was 0.1. So your numerator is 0.04 divided by 0.52. Which is, we'll just round that up to about 0.077 or 7.7%. Okay, last question. Given the team lost the game, what's the probability they were leading at halftime? So I'm going to write this in probability notation. We know for sure they lost the game. So that goes after the given symbol. We know for sure they lost the game. What's the probability they were leading at halftime? Now, we're given that they lost the game. That's what we're given. So that's our denominator. That's what we know for sure. Now look up top. If you know they won the game 52% of the time, winning the game and losing the game are complements to each other. So if they won the game 52% of the time, what's the probability they lost the game? 1 minus 0.52 or 0.48, 48% of the time. Now, my numerator is the overlap. Leading at the half and lost the game. So let's find that branch up here. Leading at the half and lost the game. That's that branch right here. So that's 0.6 times 0.2. So that gives us 0.12 in the numerator divided by 0.48. That's exactly 25% or 0.25. And that's it for today's notes.